Constructions, the 11th chapter of the syllabus. Let's see what is the essentiality for discussing about constructions. Construction, the word which comes mostly when we strike with construction, we strike in real life with construction of buildings, construction of bridges, and construction of roads. What is this construction? So let's see in brief about what construction means in the mathematical sense. Today's session is about constructions connected with the branch of mathematics. Before we get into understanding construction in detail, let's get into introduction of a real life situation. So for example, I have a bridge. This is the bridge along which I would like to construct a support. As you have here, the bridge has the support in either sides, but it needs to have a support in the middle. So my situation in case of this bridge is about identifying exactly the middle point of this bridge where I can construct a middle point. So in order to find, an engineer finds that in order to build a pillar exactly in the middle, he needs to measure the midpoint of this distance AB. Such a situation in which the end of the bridge on the left is A and the end of the bridge on the right is B, which is a line segment AB at which the engineer would like to build a pillar exactly in the middle of the bridge. So here I have the bridge problem. This purely needs the knowledge of construction. An engineer proudly uses mathematics, that is, the topic of constructions in such real life situations. How do we make the pillar supporting the bridge in the middle? Because we all know that if we have all the pillars supporting down, then the heavy vehicles passing on the top would stand with the hard concrete of the bridge, or else the bridge would fall and collapse on the ground, making more damages and casualties. Therefore, an engineer, while constructing this new bridge, is very cautious about using constructions. So here he takes the line AB and tries to measure the midpoint, which is at this point. And then he uses the three types of pillars and then constructs a bridge out here. So here is the bridge supported by the pillar exactly in the middle. That's how we understand constructions. But now the biggest question which comes is, how could the engineer identify the middle value or exactly the middle point of this length AB is the biggest question in constructions. We use this real life problem as a base to understand the topic of constructions. So let's see how the engineer has come successfully by building the three pillars exactly at equal distances so that the bridge stands perfect. A real life situation of a bridge which uses the knowledge of constructions. Constructions to be followed briefly. A student who learns construction in a regular class session needs to have the essential instruments which are essential for building up certain things, that is constructing certain things. So let's see what are the essentialities a student should possess as a stationery in order to take the topic of construction. So it is very important to note that essential instruments play a vital role in constructions, because if you want something perfect, you need to have some tools used out there. So let's see what are the tools used in order to make perfect constructions, just like the bridge in the previous session as an example case. So let's see the essential instruments. These essential instruments are also referred to as geometrical instruments. Geometrical instruments is what we note when we talk of essential instruments for construction, which are also referred as geometrical instruments. So let's see what are the essential geometrical instruments in the topic of constructions. Proceeded further. The first thing which I need is a ruler. Because ruler helps me in finding the straight lines or drawing the straight lines. For example, when I draw a straight line randomly, I may not get an exact line, but if I take a ruler and then draw a straight line, then we get a perfect straight line. A ruler drawn through a straight line as given here with the stick gives me exactly straight line, but this is said to be perfectly straight and this is said to be not that perfect, because this is randomly hand drawn and this is drawn through a straight ruler, is how we understand the basic introduction of the first essential instrument, which is the ruler. Usually a ruler has the measurements in each of its side, where it starts with 0, 1, 2, 3, 4, 5, 6, etc. up to 10, up to 20. And it has subgrids divided up to 10. So there will be 10 in number, which gives me millimeter. So here this length makes 1 centimeter, and each of the smaller lengths makes 1 millimeter. And the other side of the ruler has the measurements in inches. So here I have them in inches. 1, 2, 3, 4, 5, etc. So I have the measurements here in centimeters and here in inches, is how we understand a ruler basically with its properties. The first essential instrument in the geometrical list of instruments is a ruler, because it gives a perfect straight line, and a hand drawn does not give me a perfect straight line. Now the second essential geometrical instrument after the ruler is the compass. So let's see how the compass helps in construction of the perfect pictures or perfect diagrams. A compass out here. So what is the compass? So here a compass refers to a circle. What we have discussed needs to be perfect. Imagine I have a circle drawn by hand. I may not get a perfect circle. But if I take a compass and draw a circle, it would be exactly perfect. So if usually a compass is a fixed instrument, which is pointed, and then the other end is fixed with a pencil. So here I usually put a pencil, and then I can rotate through the compass. So here A compass usually has a pencil which can be put on the other side, and this is the pointer of the compass. And this is the pencil holder. And this here you have a screw which can be fixed accordingly. So the screw makes it fixed so that you can make it tight or loose. This string can be adjusted more tight or more lesser tight using the screw. So adjustment of the screw helps us in making the pointer fixed at one point. So I fix the pointer at this point, and then I move the pencil round depending on the distance I want to take. So this distance can be adjusted by the screw which is out here. So the suitable distance which we wanted can be adjusted by moving to and fro, and getting the fixed distance can be adjusted by the adjustment of the screw. And then with that distance, I put the pointer here and I put the pencil out here at this distance of suitable distance, and then I rotate the pencil out here, keeping the pointer fixed. Then I get a perfect geometrical circle. Construction of a circle is what is the significance of using a compass. So compass helps me draw a perfect circle or its arc. Any length of the arc is what I understand through the significance of compass. A compass helps me draw a perfect circle on its arc. Is how we understand the concept of the compass. A perfect circle which is obtained using the compass. Without a compass, the circle is not perfect, but with the compass, the circle or its arc is perfect. So the second geometrical instrument significant out here is a compass. The third essential geometrical instrument is protractor. The ruler, the compass, and now comes the protractor. Let's see the significance of protractor in the branch of constructions. Protractor. What is the significance of protractor? Just like the ruler has its significance in drawing perfect straight lines, and a compass which has its significance in drawing perfect circles or perfect arcs, similarly a protractor has its own significance. Let's see the significance of protractor in real life. It helps in drawing perfect and required angles. So here the significance of protractor is that it helps me in drawing perfect and required angles. Suppose I want to draw an angle of 30 degrees, then I have to use the protractor. So let's see how you can use protractor in applications of making certain angles. But before that, let's see how the instrument looks like. A protractor is usually a D-shaped instrument tool in which you have a center fixed and you have angles moving out here. So here we have 0, 5, 10, etc. is how each of the angles look like. And again, between the angles, I have 5 subdivided angles or 10 subdivided angles accordingly, so that everything moves till 180. So if I wanted to find, say I have here 10, 20, 30, or 10, etc., then I can make the desired angle. Say for example, I wanted to find a perfect 51 degrees. I have a line AB at which I want to make an angle of 50 degrees. So I put the protractor here and then I mark exactly at 50, and then I just draw the line from A to this. So by marking 50, I just join A and that point and extend, which gives me the angle 50 degrees exactly out here. So we can make different angles through the protractor, which usually has angles moving from here. And suppose I want to make an angle 30 degrees from B, I put the protractor out here, and then I have the other set of measurements which start from here: 10, 20, 30, 40, 50, and then I move here and then I make an angle, this, which is 30 degrees. So depending on the direction from which the angle is taken, that angle is taken on the protractor, which has two sides, one starting from here and the other starting from the left. So this is how it helps me in drawing perfect and required angles using the instrument called protractor, which is a D-shaped transparent instrument in geometrical set of list. Along with the three geometrical instruments which I have discussed, the ruler, the compass and the protractor, we also have the other set of instruments which are called set squares and dividers. So here set squares and dividers. Usually we use this instrument quite rarely, only when we need to take into consideration the special angles like 0, 45 degrees, 90 degrees, etc. And the dividers, which helps us in drawing two parallel lines. So these concepts can be understood more better if we can apply them in the problems when we solve. So these are the set of 5 instruments which are important in the geometrical instruments, starting with the ruler, the compass, the protractor, the set square and the divider is how we need to use the set of geometrical instruments in construction. One of the most important concepts in construction is that use always a sharp and a pointed dark pencil. It is not suggestible to use a light pencil because the visibility would not be clear. Hence, use always a sharp and a pointed dark pencil is one of the biggest note out here. Secondly, in constructions, we need to be careful that we do not overwrite on the construction. Draw the lines or points or arcs neatly and only for single time. Most of the students have the habit of overwriting and making it go beyond. So here, do not overwrite is the suggestion I would sincerely give to the students, because if you just draw a line and if you overwrite this in such a manner, then your point A and point B, which was actually here, because of overwriting, jumps here and This error of the difference gives the whole construction being wrong, may not be perfect. So do not ever overwrite. Draw the lines or points or arcs, whatever you take, neatly and only for single time. Do not overwrite them. So these are the two important notes which we need to take into consideration if we want to achieve a perfectly constructed diagram. Keeping in mind with these two important notes, let's see in each of the steps how to construct different diagrams using the mathematical properties to be followed with. Now that we have discussed about the essential instruments required for construction and the simple rules followed and the precautionary measures taken, that is to have a pointed pencil and a darker pencil, and about taking care of not overwriting on the constructions, let's see some of the mathematical constructions. The first thing about the construction is I want to draw the bisector of the given angle perfectly using construction. This session is about constructing the bisector of the given angle. Let's see how we can do that. To construct the bisector of a given angle, let's see how a bisector can be divided. I mean, for a given angle which can be exactly or equally divided is what we call the bisector. So let me take the angle out here. Here is the line segment AB, and here I have an angle made by this. Now this angle I would like to bisect or exactly cut with equally placed on either side. How do we do that? Using construction is how we're going to learn the first step of constructing the bisector of a given angle. So in order to do this, we have the different steps to be followed with. Firstly, I take a compass pointed at this end and I take some suitable radius. So fix the pointer of the compass out here and just draw an arc. Any arc which is of suitable radius. So take a compass and draw an arc. Now from the arc we clearly see that this arc cuts the two lines at 2 points, say P and Q. So let me mark this with P and let me mark this with Q. So I have 2 points which are formed for the arc cutting the two lines. Now let's take the pointer of the compass at P now. I move the pointer of the compass from A and put it at P. And then from here, with the same radius as taken there, I just cut, or you can take the other radius too. So we can take the different radius, but the rule is take the pointer now at Q and cut an arc with a suitable radius. Just cut an arc randomly, the piece of arc out here. Similarly, now move the pointer from P and put it at Q. So the compass pointer is now put at Q, but the radius is not moved. We take care that the screw is tight, because if the radius moves, the whole construction goes wrong. Remember, when we use the compass, the safest precautionary measure is to make the screw tighter so that the compass doesn't move along the radius. So keeping that in mind strongly, let's take the pointer at Q with the same radius as taken at P and cut with arc, and then from the pointer Q with same radius cut another arc, so it cuts in this manner. So this is how the arc cuts from Q, and this is how the arc cuts from P. They intersect at some point. So here is the point what we get. Now I have a point A and I have a point of intersection of two arcs which are joined by using the ruler. So join these 2 points using the ruler. Then I get something like this. This is how I get a line. And this line exactly makes equal angles theta and theta by this line. That means this line is the bisector of the given line. Let me take this as L. This is the bisector of the angle BAM or angle BAQ. So this is the bisector of angle BAQ as taken here. Is how we construct the bisector of a given angle. For any angle, the bisector can be constructed. So let's see each of the properties listed out in constructing the angular bisector AL. So here the rules come that firstly, draw an arc from A with suitable radius. So draw an arc from A with suitable radius. The arc which is drawn cuts the two lines at P and Q is what we have noted down. So mark them with P and Q where the arc cuts the 2 points. Thirdly, draw an arc from point P with suitable radius. It can be any radius suitable to be convenient to draw. Next, this point is very important. I draw an arc now from Q. So draw an arc from Q with same radius as this. This is very important. So I draw an arc from Q with same radius as the previous suitable radius. So therefore the two arcs meet at M. The two arcs meet at M, the point M, and then the next point is join AM. So I join AM and extend then. After you get this, that implies AM is the angular bisector for angle BAQ is how we understand the concept. AM is the angular bisector for angle BAQ. Rule 1, draw an arc from A with suitable radius. Rule 2, the arc cuts the two lines at P and Q, the line AB at P and this line at Q. Draw an arc from P with suitable radius. Take a pointer at P and draw an arc with suitable radius. Next, draw an arc from Q with same radius as the previous one. So do not move the radius of the compass, but from Q, mark with the same radius. The two arcs meet at M, as can be clearly seen here. Then join AM and extend. The line AM is nothing but the angular bisector for the given angle. Angular bisector and its construction process.